Good morning, students, and today we shall be discussing about the topic the refractive index, and we shall also discuss a couple of numericals based upon the concept of refractive index. We know that light travels with a constant speed of 3 lakh kilometer per second in vacuum, also called free space, and this speed remains unchanged under all conditions. In medium air, the speed of light is slightly less than its value in vacuum. However, for all practical purposes, we consider the speed of light in air as equal to the speed of light in vacuum, that is 3 lakh kilometer per second. However, in all the transparent media, the value of speed of light is less than this value. The change in the speed of light on passing from one transparent medium to another depends on their optical densities. Denser is the medium, lesser is the speed of light. In this context, we define a term refractive index. The value of the refractive index for a given pair of media is commonly called the relative refractive index, and its value depends upon the speed of light in the two media. We can say that the amount of change in the speed of light in a medium depends upon this property, refractive index. So, we can understand that refractive index is a measure of how much the speed of light changes when it travels from one transparent medium to other. If medium 1 is vacuum or air, then the refractive index of medium 2 is called its absolute refractive index. So let us learn about the two terms, namely absolute refractive index and relative refractive index, more explicitly. Beginning with absolute refractive index. So absolute refractive index of a medium is defined as the ratio of the speed of light in vacuum or air to the speed of light in the medium. It is denoted by the alphabet N. So we can write down that refractive index N to be equal to speed of light in air or vacuum, which is denoted by alphabet C, divided by speed of light in the medium. which is denoted by V. So we can write down N to be equal to C by V, where C is 3 into 10 to the power 8 meter per second. Now since C is greater than V, speed of light in air is greater than speed of light in any other medium. So we can write down absolute refractive index of a medium is always greater than 1. Now apart from this, we also should understand that refractive index is a pure number. It has no unit. Let's now understand what is relative refractive index. Let me draw a simple diagram for this. Let me draw the normal. This is the incident ray and this the refractive ray. This is medium 1 and this is medium 2. This is the normal. So if we consider a material medium 2 surrounded by another material medium 1 and let the light goes from medium 1 to medium 2, then the refractive index of medium 2 with respect to medium 1 is known as the relative refractive index of medium 2. The question arises how to define it. Then relative refractive index can be defined as refractive index of medium 2 with respect to medium 1 is equal to the ratio of speed of light in medium 1 to the speed of light in medium 2. So as per this definition, we can write down refractive index of medium 2 with respect to medium 1 to be equal to speed of light in medium 1 divided by speed of light in medium 2. So this, if we represent symbolically, can be written as V1 by V2. So refractive index of medium 2 with respect to medium 1 is equal to speed of light in medium 1 divided by speed of light in medium 2. Very easily, using the same relation, can we write refractive index of medium 1 with respect to medium 2? This, as per definition, should be equal to V2 by V1, isn't it? So now, if we multiply these two equations, this means so what shall we get? And that is equal to 1. Therefore, isn't it? So we can say that refractive index of medium 1 with respect to medium 2 is reciprocal of the refractive index of medium 2 with respect to medium 1. Now let us use the first equation that we have written for refractive index. On multiplying the right hand side of this equation and dividing it by c, that is speed of light, what shall we get? We will see that this turns out to be c by v2 multiplied by v1 by c, and this can be further written as isn't it? So since c by v1 is equal to n1, that is the absolute refractive index of medium 1, and c by v2 is equal to n2, that is the absolute refractive index of medium 2. Therefore we can write down n21 to be equal to n2 by n1. Or we can also write down n21 to be equal to n2a by n1a, where a stands for air. So relative refractive index of medium 2 with respect to medium 1 is defined as the ratio of absolute refractive index of medium 2 to the absolute refractive index of medium 1. Now from Snell's law we know that n21 is equal to sin I by sin of r. Therefore we can write down sin of I by sin of r to be equal to n2 by n1 as per the previous equation. On cross multiplying we get n1 sin of I to be equal to n2 sin of r. So now let us understand a couple of cases with the help of the concept of Snell's law and refractive index. When light goes from rarer to denser medium, this means if the rarer medium has got a refractive index n1 and denser medium has got a refractive index n2, then n1 is less than n2. So we can write down sin I by sin r to be equal to n2 by n1, and that is greater than 1. Therefore sin of I is greater than sin of r, which implies that angle of incidence is greater than angle of refraction. This means the refracted ray makes less angle with the normal as compared to the angle made by incident ray with the normal. Hence refracted ray bends towards the normal. Coming to the second case, when light ray goes from denser to rarer medium. So if denser medium has got a refractive index n1 and rarer medium has got a refractive index n2, then n1 is greater than n2. So therefore sin I by sine of r, that is equal to n2 by n1, that should be less than 1. So sine of I is less than sine of r, which implies I is less than r. So the refracted ray makes greater angle with the normal as compared to the angle made by the incident ray with the normal. Hence refracted ray bends away from the normal. When incident light falls perpendicular to the interface separating two media, then sin I by sin r is equal to n2 by n1, or sin of r is equal to n1 by n2 times sin of I. Now as I is equal to 0, therefore sin of r is equal to n1 by n2. Sine of 0 is 0, so that should be equal to 0, which implies that r is also equal to 0. Therefore the refracted light travels along the normal, and hence there is no bending of light, or we can say that there is no refraction of light. So these were a couple of cases that we can understand with the help of the concept of Snell's law and refractive index. Now, what are the factors on which the refractive index of a medium should depend? It depends upon the nature of the material of the medium, it depends upon the density of the medium, and it depends upon the color or wavelength of light. So now let us discuss a couple of questions based upon the concept of refractive index. The question says, find the refractive index of a material if angle of incidence is 45 degree and angle of refraction in the material is 30 degree. So very easily, by making use of Snell's law, we can find out the value of refractive index. So this will give us sine of 45 degree by sine of 30 degree. We know sine of 45 degree is 0.7071 and sine of 30 degree is 0.5. We'll put 000. So hence we can get refractive index to be equal to 1.414. This is a question based straight upon the formula. Let's solve another question. Find the refractive index of glass with respect to water, where refractive index of glass with respect to air is 3/2 and that of water with respect to air is 4/3. How to solve this question? So it is given refractive index of glass with respect to air is 3 by 2, and refractive index of water with respect to air is 4 by 3. So therefore, refractive index of glass with respect to water should be equal to refractive index of glass with respect to air divided by refractive index of water with respect to air. As per the given values, these are 3 by 2 and 4 by 3. So on solving, we get this to be equal to 9 by 8. Therefore, refractive index of glass with respect to water is 9 by 8. So in this manner, we can find out a solution to this question. Now, let's solve one more question. Values of absolute refractive index of three given media A, B and C are 1.25, 1.30 and 1.35 respectively. The questions are: which medium is optically denser and in which media speed of light is maximum. So when the values of refractive index is provided in the question, very easily by just looking into the values we can give an answer of these type of questions. Now as per the given question, the refractive index of A is 1.25, refractive index of B is 1.30 and refractive index of C is 1.35. So as the refractive index of C is maximum, hence medium C is optically denser as compared to media A as well as B. Again, we find that speed of light in the medium is the ratio of speed of light in air to the speed of light in that particular media. This means that there is an inverse dependence between refractive index and the speed of light in a media. So greater the speed of light, lower will be the refractive index. So as we can see that refractive index of medium A is minimum, that is 1.25. This means speed of light in medium A is more as compared to media B as well as C. So in such type of questions, we simply can realize the answers by looking into the values. So you can solve more number of questions based upon these formula, that is Snell's law and absolute and relative refractive indexes, and have a better understanding. Thank you.